This worksheet on reviewing solving equations is meant to help pull all of your solving techniques together and also to cover a couple special cases you might not have seen before. First of all, there's fractions. The fractions start on problem number 20, and we really want you to try solving these equations by clearing the fractions first. Some of the fractions are fairly simple, 4/3, 1/2. They're not huge fractions or weird fractions, but we still want you to go ahead and use the fraction clearing method to try to solve problems 20 through 24. What we want you to do is find the least common denominator, which in this case is 6, because you have a 3 here and you have a 2 here, and their common multiple would be 6. That 6 is going to be used to clear the fractions. If you've never done this before, basically what you're doing is choosing a number that you can multiply both sides of the equation by so that the fractions will cancel out. So we're going to multiply the left by 6, and then we're going to multiply the right side also by 6. When we do that, it's important that the 6 gets distributed to each term and not just the fraction terms. So we would have, starting with the first one, you would have 6, and it helps when you have the fractions to put over 1 times 4/3 x plus 6 times the 5. Notice it is going to both terms, not just the first one, and that's going to be equal to 6 times 1/2 x minus, and again, make sure it's going all the way over there, 6 times the 7. So the 6 is distributed on the right side also. What should happen is all the fractions should clear out. So 3 goes into 6, so this is a 1 and this is a 2. So the bottom is now gone. So we have 2 times 4, which is 8x plus 30 is equal to 6 times 1/2, and if you want, put it over 1, 6 over 2, which is 3x minus 42. So notice that we found the least common denominator, multiplied every term by the least common denominator, simplified, because it's always our first step, simplify the left, simplify the right, and then we're going to move the constants to one side. So in this case, I'm just going to subtract the 30 here from both sides. So now I have 8x is equal to 3x. Both are negatives, so that'll be minus 72. Then since I moved my constants to the right, I'm going to move my variable here to the left, and I'm going to end up with 5x on this side and negative 72 on the right side. Now my very last step is just to divide by that 5, which may appear odd because I'm left with a fraction. Fractions are okay, zeros are okay. So whatever you get, as long as your steps were legitimate, you should be fine. Leave it as an improper because we can, as long as it's reduced, and that would be your final solution, negative 72/5. So that's how we would like you to handle decimals. This example is actually written on your worksheet. The second example that is written on your worksheet is that of decimals. Now, if you remember, decimals are really just fractions. So for instance, this one is 5/100ths. This one is 15/100ths, and this one is 10/100ths. So since these are all hundredths, then we could multiply everything by 100 and our decimals would go away. So we're going to multiply this whole side right here by 100. And we are also going to multiply the right side by 100. If you recall, multiplying by 100 moves the decimal to the right twice. 2 zeros moves it twice. So that means this will move over twice and we will have 5x. When I take the 100 and I come over here to this term, this is one big term because they're all multiplied, I will end up with plus 15x minus 2. And then on this side, the 100 times the 10 hundredths will just leave me with 10x. So now I have no more decimals. This really comes in handy when you're dealing with the word problems, the application problems where you have money. Always feel free with money to multiply both sides of your equation by 100, and now you're not dealing with the decimals anymore. When we work our problems, the next step, once we've multiplied everything through by the common denominator, is to simplify the left side and simplify the right side. So by simplifying the left side, we have to distribute through those parentheses right there, 15x minus 30. This side is already simplified. Collect like terms, so 5x plus 15x is 20x minus the 30. We already have the constants on one side, the 30 is on the left all by itself, so we need to move our variables to the right. Since the constant is on the left, the variable needs to go to the right. So we're going to subtract that 20 so that it moves over to the right. When I do that, I have negative 30 on this side, negative 10 on the right side, divide by the coefficient, 3 equals x, and our properties of equality tell us that's x equals 3. We now have a solution to our problem. Now, there is one last part in this assignment that is important for you to know, and that has to do with what happens when you're working a problem and the variable drops out. So let's say that you have a problem that says x plus 3 is equal to x minus 7. Now, if you're just not paying any attention at all and you start working this out, you're going to say to yourself, okay, move the constants to the right. So you subtract a 3 going through your same steps that you always do, and you're good so far. And then you say, okay, I'm going to move my constants over to the left side. There's 1x here, so I'm going to subtract an x. When you get to this point, it's important to realize that x minus x means they're gone. So on this side, you have nothing. Not an x. You don't have 0. You have nothing. You have 0. Gone. Gone. This is canceled because they were exactly the same and you subtracted them. Then on the right side, these are gone too. All you have is a negative 10. What you have is a case where the variables dropped out and all you have is 0 equals negative 10. So you ask yourself, can I make 0 equal negative 10? Not without an x to help you. And since your x is all dropped out, you really don't have a way to make 0 equal negative 10. This is not true. 0 does not equal negative 10. You'll never make it true, so your final solution that you would write on your paper is no solution, because you can't possibly come up with an answer for that. The second example, where the variable drops out, is when you actually have a statement that somewhere along the line when you're working it out, the variables drop out and everything drops out. These two are exactly alike. But again, if you didn't notice that and you were just working the problem out, you would say, okay, I'm going to subtract the constants from both sides. Because a lot of students, you know, just start solving the problem. That's totally fine. Subtract 3 from both sides. The 3 minus the 3, it's gone on this side, equals x. The 3 minus the 3, gone on that side. Still don't notice anything. Subtract x from both sides. At any point now, you can notice that the two sides are exactly the same. Well, if the left side is the same as the right side, any number is going to work. Any number that you want to plug in for x is going to make x plus 3 equal x plus 3. So anytime as you're working this problem, you notice the left side is the same as the right side, you can stop working the problem and write the set of all real numbers. You have infinite solutions. You can plug anything you want in because x equals x. So you just write all real numbers in the set notation, and you're telling everybody that any real number in the universe will make that equation true. So when your variables drop out, make sure that you choose either no solution or all real numbers as your solution, and you should have no problem with those problems. Now you're going to work on your worksheet. If you have any questions on those 26 problems, please make sure that you ask a tutor or an instructor, and make sure that when you get to the fraction section, you clear the fractions, and when you get to the decimal section, you clear the decimals. And watch out for the variable dropping out. Turn in your papers when you're done with them.